Hello Urates and welcome back to mathematics. In today's lesson we're continuing with our topic of measurement, and we're looking at the area of basic shapes. So what we want to be able to do by the end of today's lesson is to recall finding the area of 2D shapes and convert, and what three things we want to be able to do are convert between units of area, recall the area formula for basic shapes, and apply the area formula for finding area of 2D shapes. So let's get into it. The area of a 2D shape is the total space inside the shape. So here, we've looked at, earlier in this topic, we looked at perimeter. Perimeter was the total length around the outside of a 2D shape. Area is just how much space is inside your 2D shape. And so here, unlike our perimeter, which was measured in centimeters, millimeters, meters, and kilometers, this is measured in squared units. And so what this looks like is we square the units. So, for example, if we want to measure something, we use millimeters squared, centimeters squared, meters squared, and kilometers squared when we want to measure the area of 2D shapes. So area is just a space inside our 2D shape, so the amount of space inside it, and this is measured in squared units. The first thing we want to be able to do is convert between squared units. So converting units of area. Now you might recall 2 lessons ago when we were converting between units of length, we looked at this diagram, and so here we remembered that 1 centimeter was 10 millimeters. 1 meter was 100 centimeters, and 1 kilometer was 1000 meters. And so we could use this to help us convert between different units. And what we noticed was if we went up, so if we went from small units to big units, we divided, and we went from big units down to small units, we multiplied. Now here, we are dealing with units of area, and so we want to actually deal with millimeters squared, centimeters squared, meters squared, and kilometers squared. The thing that makes this different is instead of dividing by 10, 100, and 1,000, or multiplying by 10, 100, and 1,000, we actually need to do it by 10 squared. We need to square all of these numbers. So here it's divided by 10 squared. Next one is dividing by 100 squared, and the third one is dividing by 1,000 squared, and the same thing when we multiply. Now, 100 squared, 10 squared, and 1,000 squared. Well, when we're doing this, all we need to do is we're just dividing by the number where we double the number of zeros. So here, the square just means we need double the number of zeros. For example, 10 squared, that's just dividing by 100, or 1 with 2 zeros. Notice here, we went from 1 zero to 2 zeros. When we divide by 100 squared, that's the same as dividing by 10,000, which is 1 with 1, 2, 3, 4 zeros behind it. So when we square our power of 10, the nifty little trick about it is that we can just double the number of zeros that we have, and that's the number that we're dividing by. So for example, 1,000 squared, that's just going to be 1 with, there's 3 zeros in 1,000. 1,000 squared will have 6 zeros. So here, 1, 2, 3, 4, 5, 6. And so when we're doing these multiplications or divisions, just like we noticed in the first lesson when we did converting between units of length, we actually can just use our regular tricks that we do when we're multiplying and dividing by powers of 10 and moving our decimal point. So here on the other side as well, it's just the same number as the ones that we have above. So that's just the same thing as this. Okay, so let's have a go at a couple of examples of converting between units of area. So here, example number 1. I'm going to move this up so that we can actually have this diagram here available for us. Convert these area measurements to the units shown in the bracket. So we want to convert our measurements from the units that we're starting off with to the units in the bracket. So let's start off with the first one. 859 millimeters squared, and we want that in centimeters squared. So if you remember from our first lesson, millimeters to centimeters, we need to divide by 10. But because we're dealing with millimeters squared and centimeters squared, we need to divide by 10 squared. So here, this becomes 859 divided by 10 squared centimeters squared. Okay, now dividing by 10 squared is the same as dividing by 100. So I'm just going to write here 859 divided by 100 centimeters squared. And just like we did in the last lesson, when we divide by powers of 10, we just count up the number of zeros. 1, 2, we've got 2 zeros here, and we just move the decimal point to the left. So if we're dividing, we move it to the left. So here the decimal point, which is after the 9, it just moves 2 to the left, 1, 2. And so this just becomes 8.59 centimeters squared. Okay, So here, when we're dealing with squared units, we need to square that conversion. So instead of just dividing by 10, we're dividing by 10 squared. And that's just going to be 10, 1 with 2 zeros behind it. So we double the number of zeros that we have. Okay, next one is 2.37 meters squared, and we want to convert to centimeters squared. Now, if you have a look here, meters squared to centimeters squared, that's the second arrow. I should have done the arrows for the first one, but that's okay. And that's just timesing by 100 squared. So here, this is just going to become 2.37 times 100 squared centimeters. Because when we're converting from meters to centimeters, instead of meters squared to centimeters squared, instead of timesing by 100, it's timesing by 100 squared. And so here, when we want to figure out what this is, that's just going to be 2.37 times by, we double the number of zeros. So here we have 2 zeros and 100 to begin with. And so 100 squared is just going to be 1 with 4 zeros behind it, centimeters squared. Okay, and when we're multiplying by powers of 10, we count up the number of zeros, 1, 2, 3, 4, there's 4 zeros, and we just move the decimal point 4 spots to the right instead. So here, 1, 2, 3, 4. And whenever we have those loops without anything in above them, that just becomes 0. So that's 23700, so 23,700 centimeters squared. Okay, so that's that example there. Let's have a look at the last one. 1,437,000 meters squared, and we want to convert that into kilometers. So here, when we're converting from meters squared to kilometers squared, we're dividing by 1,000 squared. So it's not 1,000, it's 1,000 squared. So here it's going to be 1,437,000 divided by 1,000 squared, kilometers squared. And so when we want to figure out what that number is, we just double the number of zeros. So 1,000 has 1, 2, 3 zeros. So when I double it, it becomes 6 zeros. So 1,437, 1, 2, 3 divided by 1, 2, 3, 4, 5, 6. 6 zeros, kilometers squared. Okay, and because we are dividing, we're going to move our decimal point to the left. So we count the number of zeros. So here we've got 1, 2, 3, 4, 5, 6. I've got 6 zeros. My decimal point is here. I'm going to move it to the left 6 times. Here we go. 1, 2, 3, 4, 5, 6. And so here, this just becomes 1.437 kilometers squared. So that's how we convert between units of area. When we're converting between units of area, we need to make sure that we divide or multiply by that conversion squared. It's not 10, it's not 100, it's not 1,000, it's actually 10 squared, 100 squared, 1,000 squared. So that's what we need to make sure that we do when we're converting between units of area. Okay, so that's how we answer these questions on converting units of area. The next thing we need to do is we need to actually calculate the area of different 2D shapes. So to find the area of most shapes, multiplication is usually involved. So usually when you're trying to find the area of a 2D shape, you need to use multiplication. But in particular, we actually need to use the correct formula for our particular shape. So here we need to refer to a few area formulas for different shapes. So here we've got 3 shapes that we're going to be looking at: a rectangle, a square, and also a triangle. So let's talk about the rectangle first. The rectangle, now if you have a look, there's 2 things that we need when we're finding the area of a rectangle. What we need 2 measurements. The first one is the length of your rectangle. So here I'm going to call this L for my length. And the second thing is I need my breadth, or B for our breadth. Now here, sometimes different people use different letters. You might use LW or LH or BH. They all refer to the same thing, the length and the breadth. So we only just need one measurement in one direction and another measurement in the other direction for our rectangle. And all we do is we multiply the two. So here that's just going to be L times B, or with algebra we don't write that multiplication symbol, so this just becomes LB. So when we're trying to find the area of a rectangle, all we need to do is we multiply our 2 lengths, L and B. Now, when we looked at perimeter, what we did was we added all of these together. When we look at our area, you don't want to multiply all 4 of the sides together. You just pick the 2 that are perpendicular or meet at 90 degrees, one in one direction, one in the other direction, and multiply those 2 together. That's all you need. You don't need any other ones. Okay. The next one is a square. Now with a square is just a special rectangle. So we can actually use our formula for a rectangle for our square. But here, because it's a square, what we notice is that all of the side lengths, this one here is going to be the same length as this one here. And so if one of them is called L, for example, the other one is also going to be called L. So when I find the area of my square, that's just going to be L times L. Sometimes some people sometimes refer to this as S for the side length of our square, but here I'm just going to use L just to keep it the same as our first one. And so here the area of my square is going to be L times L, or another way of writing this is L squared, length squared. And so for our square, it's just a special example of a rectangle. And here we're just going to use the same formula, multiply those two, one in one direction, one in the other direction. And in this case, because all our lengths in our square are the same, L squared. Okay, the final one is our rectangle. Now a triangle. Now our triangle is a little bit different. The triangle is actually half of a rectangle. And so what we do here is we use two separate measurements. The first one is this measurement here. This is called H, and what we need to make sure for H is that it's perpendicular. What this means is that it needs to be perpendicular or be at 90 degrees to our other measurement. And we call our other measurement, this length over here, our base length, or B. And so when we're trying to find the area of our triangle, that's just half times H times B. So here it's just half times H times B, or sometimes you write it in the other direction, other order as well. You could write it as half BH, but we can just write this as half HB. Actually, I'm going to rewrite it as half BH because I think I'm just more used to that one. My bad. B times H, so half BH. An important thing to notice is that we need to make sure that our height is perpendicular. It's at 90 degrees, just like the other ones. Notice here, all our length and our base, they meet at 90 degrees. These all meet at 90 degrees. So here, we need to make sure that our height is at 90 degrees to our base. Okay, so these are the area formulas that we need to use. So when we're actually using these formulas, what we want to do is we want to firstly identify the shape that we are given. So identify the shape we are given, and then write the formula for that shape. The writing out the formula is actually helpful for us just to know what measurements we need. Then the second thing is we need to identify what measurements we need for the formula. For our rectangle, we need the length and the base. For our square, we just need the side length and then we can just square it. And for our triangle, we need to have our height and our base. And we need to make sure that we can find the correct measurements there. Then once we've done that, we substitute the measurements into the formula and we put them in. Okay. So that's how we use these formulas. So here we're going to refer back to these three formulas to help us find the area of our 2D shapes. So let's have a go at a couple of examples. Here, find the area of rectangles and triangles. So find the area of the following shapes. So here we've got two shapes. I'm going to call them A and B. A and B. So let's have a look at the first one. Now if we have a look at the shape, what shape is this? Well, this one is a rectangle. And so with our rectangle, the area formula is just L times B, or LB. What I then need to do is just find those measurements. I want to find how long L is and I want to find how long B is. So from my diagram, my length is just going to be 6 centimeters and my breadth, B, is going to be 2 centimeters. So here I'm going to have 6 times 2. And because we've got centimeters and centimeters in our measurement, we're going to write centimeters, but because it's an area, we want to write that as centimeters squared. Remember, area is measured in squared units. So I'm going to write here centimeters squared. Very important. If you write centimeters, you're not right. That's not right. So here, we need to write it in centimeters squared. Okay, so 6 times 2, that just gives me 12. And so here, for this one, my area is just 12 centimeters squared. Okay, so just remember, we need to find those two measurements, L and B, find the correct formula to substitute it into, and just substitute those values in. Let's have a look at this next example. Now this one here, this shape, this is a triangle. And so the formula for the area of a triangle is half BH, half times the base times the height. So here we need to find what the base and the height are. So if I have a look at my diagram, my base is my 13 meters here, and my height is this 7 meters here. So I'm going to write half times 13 times 7. Okay, now, just like we did in the first one, the measurements here are all in meters. So if I want to write the units for this, it's going to be meters squared, because area is measured in squared units. I need to square whatever units I have. So I need to write this meters squared. Okay, and then I can just calculate what this is. Now, if you're not sure how to calculate this, you can put this in a calculator. Now, I'm pretty sure this will give me 45.5, but let's just check that. So I'm going to go half times 13 times 7, 45.5. So this tells me that this is 45.5 meters squared. So there we go. That's how we can calculate the area of our shapes here. So when we want to calculate the area of a 2D shape, what we want to do is firstly identify what type of shape we have. Is it a rectangle? Is it a square? Is it a triangle? And then from there, write down the formula. So here, my rectangle, my area formula was A is equal to LB. For my triangle, A is equal to half BH. Then once we have that formula down, we can actually identify what measurements we need. So have a look at the letters that we have. For my rectangle, I needed L and B. I needed my length and my base, and I just multiply those numbers together. For my triangle, I have B and a H, and I need to find the base length and the height. And so once I've done that, I can substitute that in. The other important thing is to remember that your measurements are in squared units. Squared units. Area is measured in squared units. So you need to make sure that you write that square or that little 2 with our unit at the end. Okay, so that's how we can find the area of 2D shapes. Now, we can actually build off of this and actually find the area of a composite shape. Now, a composite shape is a 2D shape which is constructed using multiple shapes. So we can use multiple shapes and build them and construct them to make a shape that's combined with different shapes. And this is either they're added or subtracted from each other. So you can take two shapes and just put them together, or you can take two shapes and take one and subtract that area from it. So what we want to be able to do is calculate the area of these composite shapes. So when we're doing this, the steps are, first, identify what shapes make up the composite shape and how it's made. So did they use addition to make this shape? Or did they use subtraction to make this shape? Did you add two shapes together, or did you just take one shape and subtract another one from it? Then part 2, we find the area of each shape. So we use those formulas we have up here and find the area of each shape. And the third step is then we apply the correct operation identified in step 1. If we're adding, we just add those areas together. If we're subtracting, we subtract those two areas from each other. So let's have a go at 2 examples here. Find the area of these composite shapes using addition or subtraction. So let's have a look at this first one. Now, if you have a look at this first one, what has happened to make this composite shape? Well, if you have a look, we've got a rectangle here, but from this rectangle, we've actually gotten rid of a triangle. And so here, this is a composite shape made by subtraction. So I'm actually going to write down an equation just to help me figure out how to find this area. So area, I started off with my pink rectangle. So I'm going to write A, and just to show that it's for my rectangle, I'm going to write a little subscript. Subscript, it just means I'm specifying which one it is. A of my rectangle. So the area of my rectangle. And then from my area of my rectangle, what did I do? I subtracted the green area, that green area of my triangle. So I'm going to subtract the area of my triangle. Okay, so what we need to do is we need to find the area of the rectangle, and I also need to find the area of my triangle. So, like we did in the previous questions, I'm going to write the formula down for each one. So the area of my rectangle, that was just L times B, and the area of my triangle is just half BH. Now, let's have a look at the rectangle. Now, I need my length and my base. So if I have a look at that rectangle, so let me have a look at this pink section. My rectangle, what's my length and my base? Well, my length is going to be this measurement here, so 10 meters, and my breadth, or my base, is going to be 6 meters. So here, I'm just going to write 10 times 6 minus. Now, for my triangle, I need half BH. So we're going to look at the triangle now. Now, if you have a look at the triangle, what is the base and what is the height? Now, even though we had the same B letter here, we need to make sure that we've got the correct measurement for B. Now, my base is actually the measurement from here to here. Now, in my diagram, that's actually the same as this 10 meters over here. So for my B value, that's just going to be 10. So I've got minus half times 10 times the height, if you have a look inside that triangle, is this measurement here of 4 meters. So I'm going to be half times 10 times 4. Now let's talk about the units that are measured here. So here, all the measurements are in meters. So my final answer is going to be in meters squared. Just remember, area is measured in squared units. Okay, so I can substitute these values in. I can calculate this and figure out what the final answer is. So here, 6 times 10, that gives me 60, minus half times 10 times 4. Now, half times 10 times 4, all I need to do is just take half of 10 times 4. What's 10 times 4? 40. Half of that is 20. So here I've got 60 minus 20 meters squared. And so I get a final answer of 40 meters squared. So for this example, we need to identify what shapes we have. So if for my two shapes, here I've got my, for these two, in my composite shape here, I've got my rectangle and my triangle. And so what we did was we went, okay, how did we make up that shape? Here, we subtracted the area of the triangle from the rectangle. And so here I wrote that down as area of my rectangle minus the area of my triangle. Then just like we did in the previous questions, we find the area of each of those shapes. So here I used my area formula for my rectangle and the area formula of my triangle, and I need to subtract them. We find those areas and then we subtract them and we get a final answer of 40 meters squared. Okay, let's have a look at the second example, B. Okay, let's have a look at this shape. Now, if you have a look at the shape, there's a few ways that you could answer this, but let's have a look at breaking down the shape into two shapes. Well, when I look at this, actually, I go, okay, hang on, I can break this down into two parts. I've got this part over here. And if you have a look, well, I've got these dashes, which tell me that this is going to be 3 millimeters, which means that this shape is a square. And then on top of that, I have this other shape over here. And we've got these measurements, 1 millimeter and 1.2 millimeters. So this is a rectangle. And so here I am adding these two shapes. I'm adding the square and I'm adding the rectangle to help me find the total area. So for this one, I've got A is equal to area of my square plus the area of my rectangle. And so I can just write down the area formulas for both of these. So here, this is just L squared is the area formula for my square plus L times B for my rectangle. So I've identified what shapes I have and what formulas I need to use to find those areas. All I need to do is just identify those lengths. So for my square, I need L squared. So I just need one side length for my square. In this case, the side length of my squares just happen to be 3 millimeters. So notice here, both of these measurements, that's just 3 millimeters. So I'm just going to have 3 squared. Plus, then I look at my rectangle and I need the length of the rectangle and the breadth of the rectangle. So here the rectangle has a length of 1 millimeter and a breadth of 1.2 millimeters. So this is going to be 1 times 1.2. And for my measurement, they're all in millimeters. So I'm going to write here millimeters squared. Okay, let's find those areas. So 3 squared just gives me 9. Plus 1 times 1.2 is 1.2 millimeters squared. And because I'm adding those two areas, I just add them 2 in the end. So here I've got 10.2 millimeters squared. So there we go. That's how we can find the area of our 2D shapes here for composite shapes. So what do we do? We firstly identify what shapes we have in our composite shape. So for our second one, we had a square. The pink area was a square, and we had a rectangle in the green. And then we notice here we can add those two areas together. Then we identify the area formulas for both of those shapes, and then we calculate the area, and then we added them. So that's it for today's lesson. Let's do a quick recap. In today's lesson, we talked about area. The area is just a total space inside a 2D shape. And this is measured in squared units. So we want to make sure that when we're dealing with area, these are in squared units. Millimeters squared, centimeters squared, meters squared, kilometers squared. The first thing we looked at in this lesson was converting between units of area. And here we used our same unit conversions for length, but what we did was we squared our numbers. So here we did 10 squared, 100 squared, 1,000 squared. And what we noticed was that if we want to find out what that number is, we just double our number of zeros. So 10 squared was 100, so 1 and 2 zeros. 100 squared was 10,000 and 1 with 4 zeros. And 1,000 squared was 1,000,000, which is 1 and 6 zeros. So we actually went through converting between units of measurement. Then we also went through finding the area of a few basic shapes. And so here we had to use our three formulas. For our rectangle, that was just length times base, or LB. For our square, that's just our side length square, or L squared. And our triangle, that's just half a rectangle, or half times B times H. And so when we're trying to find the area of a shape, we have to identify what shape we have, correctly identify what formula we need to use, and then figure out those measurements that we need for our formula, sub it in, and then find the value. And we also looked at composite shape. And so we had to identify how those shapes were made. Was it added together or was it subtracted from each other? And then find the areas of those shapes and either add or subtract them. So that's it for today's lesson. Hopefully that helped. And as always, Year 8s, I hope you guys are staying safe wherever you are. And I'll see you in the next video. Bye.